All right, let's do section 5.3. And this first problem says solve the equations algebraically and check graphically round to 3 decimal places. So 1600 equals 10 to the x is the first problem. Okay. Now this is an exponential equation. I'm not sure we've solved any equations like this yet. I want to show you how to do it. The first thing you want to do is take the log of both sides. And you either want to use common log or natural log. I'm going to use natural log. It really doesn't matter though. And remember, the notation for the natural log is ln. The notation for common log is just log with no base. Now here's the key step. Once you take the log of both sides, you can use an exponential property to bring this x out in front of the logarithm. So there is something called the power rule that says you can bring the power out in front of the logarithm. The right-hand side really reduces to x times natural log 10. So that's a key step right there. And again, that's the power rule. So once we do that, if you keep in mind that natural log 1600 and natural log 10 are just numbers, you can get x by itself by dividing both sides by the coefficient of x, which is the natural log of 10. So our answer is natural log 1600 over natural log 10. And on the test, I want to make sure I make this clear, I'm going to look for the exact answer of these exponential equations. Because I think you can do these things with the calculator, but in order to make sure that you're doing it the correct way, I'm going to look for the exact answer in addition to the decimal approximation. Well, let me plug this into a calculator. And this is just natural log 1600 divided by natural log 10. So I get 3.204. All right, and remember the natural log key is right there. So if I wanted to find natural log of 1600, I just press natural log, and then you see that left parenthesis, enter the 1600, close the parenthesis before you say divided by natural log 10. And I think on another video I showed you how to do it on the Inspire. So let's move on to the next problem, number 5 in the book, which is really number 2 for your online problems. 8900 equals e to the 5x. And keep in mind that e number is about 2.71828. It's an irrational number. I think I've mentioned it several times, but that is not a variable, it's a constant. And in this case, I'm going to do exactly what I did on the first problem, which is take the natural log of both sides first, and then use the power rule to bring that exponent out in front. So the 5x would come out in front of the natural log of e. And the very last step is to divide both sides by the coefficient of x, which in this case is just 5 natural log e. That gets x by itself on the right-hand side. And entering the left-hand side into a calculator is a little bit tricky, but you can do it. You just have to be a little bit careful. Well, let's see what the decimal approximation is. I get 1.819. You know, you could check your answer by plugging 1.819 into the original equation and make sure the left-hand side equals the right-hand side, but I think that's it. Let's move on to number 3, which is really number 7 in the book. And this one is somewhat similar to the last one. But there is one little difference that I want to consider. And that is this. It's tempting to just take the log of both sides like we did on the last couple of problems, but if you happen to have a number in front of the exponential expression, divide both sides of the equation by that number first. And that is very important to do that first, before you take the log of both sides. Alright, it does make the equation a lot nicer, but it's not just that. If you just try to take the log of both sides, it makes the equation a lot more complicated to work with. But you know, you can, if you want to, take the common log instead of the natural log. It'll work out just as well. So I kind of prefer the natural log, but the common log is fine. And once you do that, use the power rule to bring that exponent out in front. Alright, now divide both sides by the coefficient of x, which is 8 log e. That gets x by itself. And just be real careful about how you enter this into the calculator. Again, make sure you close your parentheses around the 20 and also the e. And you might want to put this whole denominator in parentheses too. But practice with your calculator too. I'll tell you what I get. .374. All right. Let's move on to the next problem. Number 4. And this is number 13 in the book. This one says, use a change of base formula to evaluate each logarithm. Round answers to 4 decimal places. Log square root of 2 to base 8. So, unless you have the Inspire calculator, you can't evaluate something like this because the base is not 10 or e. But there is a nice formula that allows you to convert any base to base 10 or e. And here's the trick. I kind of prefer the natural log, so I do this. It's the natural log of the big number over the natural log of the base, which is the little number. And that's essentially the change of base formula. And it ends up being 1/6. By the way, you can, if you want to, use common logs instead of natural logs. The common log of the square root of 2 over the common log of 8 will also give you 1/6. I'll double check it with a calculator, but it should. It does. Well, let's move on to the next problem, number 5. And this is another exponential equation. 8 to the x equals 1024. Actually, I wanted to do this one. 2 times 5 to the 3x equals 31,250. Now, once again, notice you have a number in front of the exponential expression. So make sure you divide both sides by that number before you log both sides. If you forget that little step, it's going to mess everything up. And I want to emphasize again that on the test, I will be, well, actually, I guess I won't be physically grading the test. But I get 15,625. All right. And the rest of the problem is kind of similar to what we've already done. Take the log of both sides. Use the power rule. So if I take the log of both sides, again, bring that exponent out in front. and divide both sides by the coefficient of x. So that is your exact answer. Plug all that into a calculator. And I ended with just a 2, so a nice little answer. Well, I think I'm going to go ahead and finish this section on another video. So this is just part 1 of section 3.5.